Welcome to this video on refraction through lenses. This is the third in the series. In this video we're going to talk about concave lens. So here is a concave lens. You can see a concave lens. It diverges the beam, the parallel beam that comes from the left. To construct this concave lens, we start with two spheres. Here are the two spheres. This is sphere number 1 and sphere number 2. And once we have these spheres positioned like this, then we cut the section. So we cut the sphere such that only the following section remains. So this is the only section that remains. So thus we get a concave lens. The terminologies applied here are pretty much same as that of convex. You have two center of curvature. Since light falls first on this surface, we say this is the first center of curvature and this is the second center of curvature. Just like in convex lens, you also have the optical center. So this is your optical center, and the line connecting the center of curvatures are called principal axis. Just to remind you, this is how the convex construction was. In this, the rays come from the left, and since this is the first surface that it hits, we say the C1 is here and C2 would be here, because this would be the second surface. So this will be a first surface and second surface. So this is C2. So it's just that it's a reverse in case of convex, and the rest of the concepts are pretty much the same. Here is a prism, which is an approximation of a concave lens. So this whole prism is constructed like this. So you have an inverted prism. So this is very handy to study the behavior of what happens or why the rays are diverging. So as the rays comes here, the prism naturally diverges these beams. Sorry about this one. Yep, like that. Now that's what is happening in this diagram that you see. The three beams are being diverged, and if you extend this diverging beam back, it meets at a point, and that point is actually our principal focus in a concave lens. So in this case, you can see this is about 8.4 centimeters, and that would be the focal length of the concave lens. So this is a focal length, and since it's on the left side of the origin, this focal length is negative. So as you can see, this is negative 8.4 here, and this line that you see here is the focal plane. This is called the focal plane. So if there were three rays that goes in like this, they would still converge in this focal plane as follows. So here are the divergent rays, and if you would extend them backward, they would still converge in the same plane. So that's why this is the focal plane of the concave lens. Let's look at a phenomenon of what happens when we use a thicker concave lens. So when we use this is a thinner concave lens, and when we replace it by a much thicker concave lens, you see that the divergence is much more. So a thicker concave lens results in much more divergent ray than a thinner concave lens. Here is a visualization of the ray diagram for both these cases. So here is the thicker lens, and we can see that in a thicker lens the rays are much more divergent, and the focal length is much smaller. And in the case of a thinner lens, the focal length is much more than the thicker one, right? So in general, the thicker the lens, shorter the focal length, and more divergent the rays. All right, so with this perception, now let's move to the idea of what is a primary focus, a secondary focus, and a principal focus in the context of a concave lens. The definition of a secondary focus is, if you have rays coming in from the left, which is usually the convention for all the ray diagrams that we will use. So if you have these rays coming in from the left, the place where these rays meet is called the secondary focus, and that's the definition we used in convex lens, and we use the same definition. But here the problem is these rays are not converging, they are diverging. So what we do is we extend these rays backwards, and this point for us is the secondary focus. Unlike in a convex lens, so in a convex lens, you have these rays, if this is your principal axis, these rays meet here, right? So this becomes your secondary focus. So that's the definition of the secondary focus. And the definition of the primary focus is, where the rays would meet if the parallel rays are coming in from the right side. So let's draw parallel rays coming in from the right side. So if these are the parallel rays, then they would of course diverge. So these are the parallel rays. So they would diverge. And if you extend these rays backward, this is the primary focus, F1. Right? And the same definition holds true for the convex lens. The rays coming parallel wherever they converge, and here the convergence would be here, right? So here the convergence would be here. So this is my primary focus. So that's a summary. The secondary focus for a convex lens is on the right, and for concave lens is on the left, and the primary focus is on the right for concave and left for the convex. Okay, now the principal focus is always the secondary focus. Once we position the lens, in whatever way we position, then the principal focus is always taken as a secondary focus. So in case of a convex lens, this becomes the principal focus. In case of concave lens, this becomes your principal focus. Now usually we don't use the word principal, and we just use the word focus. By focus we actually mean the principal focus. Finally, in this chapter we are mostly dealing with what we call as equiconvex and equiconcave lens. By this what we mean is my primary and secondary focus are equal. So it does not really matter whether if you write F1, F2, you don't need to write all that. You can just write F and F because the focal length is same. But just remember that for a concave lens your focal length focus is on the left because we always consider object or rays are coming from the left side. So that would imply that we are talking about the where it meets, that's a secondary focus. And for concave lens, convex lens, F is on the right because that's what would happen to a parallel ray if it comes from the left. All right. Now one last thing. So which one would be a thicker lens? So take a guess. If F is minus 5 centimeters and F is minus 10 centimeters. So the question is, which one is thicker and which one would diverge more. So think about it. If your answer is this, you're right. So yeah, so the focal length is smaller means more thicker and more divergent in the concave lens. So finally, I would urge you to go through the learning goals and see if you can reconstruct the narrative in a paper, and if you can't, then I would urge you to refer to this video again. See you in the next one, where we will see how these behaviors will result in a particular type of image for both these lenses. Ciao.